Hi Physics, this is Miss Adderley. I'm going to talk about acceleration in this video. So acceleration is change over time. And this is the video that we'll do practice problems with. The equation that we'll use for acceleration problems equals A equals VF minus VI over T. Again, the A is going to stand for acceleration. VF is our final velocity, and VI is our initial velocity, which we know that. And then T is going to stand for time. Just to go over this so we have our units, acceleration is actually going to be meters per second squared. Final velocity, initial velocity are both meters per second, and then time is seconds. Now, if we derive this problem, we're actually going to have a couple more equations. So VF, if we're trying to solve for VF, it's going to equal VI plus AT. If VI is 0, then it would just be VF equals A times T. So it's just going to depend on if you have a value for initial velocity or if you have to assign a value of 0 for initial velocity. We may also see T equals VF minus VI over A. So if we want to solve for time, and if we were going to solve for VI, it would be VF minus AT. We're not really going to use this equation. It's going to be more of finding acceleration, final velocity, or time. So these are our formulas for acceleration. So we're going to do a couple practice problems to practice this work. All right, example number 1. Grace is driving her sports car at 30 meters per second when a ball rolls out onto the street in front of her. Grace slams on the brakes and comes to a stop in 3 seconds. What was the acceleration of Grace's car? So first we're going to write our given. We have a value of 30 meters per second. So we have to determine, is that the initial or final velocity? And the key is she is driving her sports car, which means it is her initial velocity. We're also given a time of 3 seconds. And we want to find the acceleration. So we do need a VF. If she's slamming on her brakes and coming to a stop, then that means our final velocity is 0. So the next thing we need to write is the equation that we're actually going to use. This would be A equals VF minus VI over T. And then we just plug in the numbers. So A equals 0 meters per second minus 30 meters per second over our time, which is 3.0 seconds. So if you notice here, our value is actually going to be a negative. That's because she's decelerating and she's slowing down. So after we put that into our calculator, we're actually going to get the acceleration is 10. Now since there's 2 sig figs here and 2 here, we need to make sure our answer also has 2, which means I need to add a 0 right here in order to make that have 2 sig figs. The last thing I will do is put my meters per second squared and then circle my answer. So that's our first example. Again, all of these examples are actually going to be in the homework. So what I would like you to do is not just copy down the answers, but try to do the work yourself and see if you do it correctly. So you have something to check yourself. Okay, we're going to do example 2 now. A jumbo jet taxiing down the runway receives word that it must return to the gate to pick up an important passenger who is late to his connecting flight. The jet is traveling at 45 meters per second when the pilot receives the message. What is the acceleration of the plane if it takes the pilot 5 seconds to bring the plane to a halt? So again, we're given a value, 45 meters per second. It's going to be our initial velocity, because that's how fast the plane is going. It's halting to a stop, which means our final velocity is going to be 0. We are given a time, which is 5 seconds. And we want to know, what is the plane's acceleration? So we're going to use the same equation as last time. A equals VF minus VI over T. I'm going to plug in my numbers. So 0 meters per second minus 45 meters per second over 5 seconds. You'll notice again that our answer is going to be negative, and that's because we're de-accelerating or slowing down. So when I put this in my calculator, I actually get an answer of 9. I want to have, this has 3, this has 3, so my answer needs to have 3 sig figs. So in order to make it follow sig fig rules, I need to add 2 zeros at the end. And then as always, we must remember to put our units. So this answer is negative 9 meters per second squared. Sample 3. While driving a sports car at 20 meters per second down a 4-lane highway, Eddie comes up behind a slow-moving dump truck and decides to pass it on the left-hand lane. If Eddie can accelerate at 5 meters per second squared, how long will it take him to reach his speed of 30 meters per second? So I need to do my given. So we have 2 velocities in this problem. We have 20 meters per second and 30 meters per second. So 20 is what he's starting at, so that's our VI. 30 is what he wants to get to. We're given an acceleration of 5.0 meters per second squared. And we want to know how long it would take for him to pass the car. Again, when we do our equations, we need to write the equation that is the derived version. So make sure you're doing that every single time. So T is VF minus VI over A. So I'm going to plug in my numbers here. We have 30 meters per second minus 20 meters per second over 5 meters per second squared. So we actually would cancel this out and leave us only with seconds left over. And before we write the answer, this has 3 sig figs, 3 and 3. So our answer also needs to have 3 sig figs. Whenever I put this into a calculator, it's going to be 10 over 5. So our answer is actually going to be 2.00 seconds. So we want to make sure we have 3 sig figs. And I like to box in my answers when I'm finished. So that is a problem showing you how we would solve for the amount of time that we need. We're going to do one more example problem. So Monica is walking to the hairdresser at 1.3 meters per second when she glances at her watch and realizes that she's going to be late for her appointment. Monica gradually quickens her pace at a rate of 0.090 meters per second squared. What is Monica's speed after 10 seconds? So we need to write what we're given. We're given 1.3 meters per second. And that's going to be her initial velocity because that is how fast she's moving at the current time. We're also given an acceleration of 0.090 meters per second squared, and we're given a time of 10 seconds. So this time we're going to use the equation to solve for VF. So VF equals VI plus AT. I'm going to plug in our numbers here. So VF equals 1.3 meters per second plus 0.090 meters per second squared times time. And I'll put that down here because I'm running out of room. Again, I would multiply these together and then add it to the 1.3. And after I do all of the math, we're going to end up with an answer of 2.2 meters per second. So how we would do sig figs for this is this has 2 and this has 3, but you would do the least amount of sig figs. And then also when you're adding, it shows you right here that you need to have 1 decimal place with it. So that's how you do sig figs for this problem. Again, if you have any questions on sig figs, please let me know anytime you're doing any of the math problems. I have posted problems. There's 10 of them. 4 of them I have already given you the answers to. Again, I am putting those problems on there again so you have the ability to do them on your own and look back and make sure you did them correctly. So that's why I'm doing this. So you have some practice with those problems. And then there's 6 other problems that I have not done yet. So that's the end for acceleration. Acceleration isn't too complicated. There's just a couple versions of the equation. Whenever we take the quiz on this, and there will be a quiz on Monday, if I ask for given, this is what I'm looking for right here. What I'm given in the problem itself. When I want the equation, I do not want to see A equals VF minus VI over A 5 times. I want to see the equation you actually used. So you need to be showing me the derived equation. Whenever we do work given, answer, you can just do that. If you would like to include the units with your answer, there's nothing wrong with that, but please do not put all of your work, just put the answer. And then the last thing I always ask for is the correct units, which would just be this. Again, please only put what I am asking. Do not put everything in every question for the next quiz. Again, if you have any questions, please let me know. Have a nice day. Bye.